Hi everyone, welcome to my YouTube channel, Zenith GATE Mechanics. So in the today's session, I will discuss the questions which came into the GATE 2025 from the machine design subjects. So the first question is, the yield stress of metal in uniaxial tension is given as 200 megapascal according to the von Mises criteria. The yield stress of the metal in pure shear you have to calculate, and there are the four options. Okay. So what is the data given? The yield tensile strength is given as 200 megapascal. And according to von Mises criteria, according to von Mises yield criteria, you know the relation between the yield shear strength and the yield tensile strength. So the yield shear strength is nothing but the yield tensile strength divided by root 3. So the yield tensile strength is given as 200. If you divide with root 3, then you will get 115.47 megapascal. Okay. So that means approximately 115.5. So the correct answer for this question is option C. So option C is the correct answer for this question. Choice C is the correct answer. Now, the next question is, a shaft carries a helical spur gear. Which one of the following bearing cannot be used to support it? Okay, one shaft is there, which basically carrying the gear, which is a helical spur gear. Which one of the following bearing cannot be used to support it? So you have to identify which bearing cannot be used to support the helical spur gear. So there are the four options: the double row ball bearing, angular contact ball bearing, tapered roller bearing, straight roller bearing. Okay, so first try to understood what different kind of load the helical gear can bear. So this is the helical gear. So the helical gear is basically nothing but the teeth. If you see, these are not parallel to the shaft, not parallel to the shaft axis. Let us suppose this is the shaft on which the gear is mounted. So the shaft axis in this direction, but the teeth are cutting at some angle. So the helical gear means the teeth are not parallel to the shaft. So what are the different kind of load it can bear? So the helical gear generates both radial and axial load. Radial and axial load due to the angled teeth. That means the teeth are not straight parallel to the axis. It is having some certain angle. So the bearing should be handle both axial and the radial load. So because the shaft is carrying the helical gear, it is generating both radial and axial load. So you have to use the bearing which can handle both axial and radial load. Now, if you see the four options, the first option is double row ball bearing. So double row ball bearing is basically handling both the type of load. That means a radial load as well as some axial load. Similarly, the angular contact bearing, it is also specifically designed to bear both the types of load. That means the radial load as well as the axial load. But if I talk about the tapered roll bearing, this tapered roller bearing can also be used for bearing the axial load. That means the high value of axial load as well as the radial load. That's why it is suitable for this helical gear. But if I will talk about this straight roller bearing, the straight roller bearing only supports radial load. It cannot support the axial load. So you have to identify which bearing cannot be used for helical spur gear. That means the straight roller bearing is the correct answer. Straight roller bearing is the correct answer. Why? Because the straight roller bearing straight roller bearing, straight roller bearing, it supports only radial load. It cannot support, or it cannot handle axial load, which is basically present in, which is present in a helical gear, which is present in a helical gear. So what will be the correct answer? So the correct answer for this question is nothing but option D. So the option D is the correct answer. Choice D is the correct answer. Okay. Now, the one more question from the welding, from the welded joint. Two plates of thickness 10 mm each are to be designed by a transverse fillet weld on one side, and the resulting structure is loaded as shown in figure. Okay. So these two plates are welded at this point, and they are subjected some kind of load, which is nothing but 5 kilonewton. If the ultimate tensile strength of weld material is 150 megapascal. Okay. So the ultimate tensile strength is given as 150 megapascal, and the factor of safety is given as 3. So you have to identify the minimum length of weld so that the weld does not fail. So what will be the minimum length of weld so that the welding, or whatever the weld which you have done, it should not fail. Okay. So how you will do this problem? First of all, let me write the data, whatever the data which is given. So the H value, which is nothing but the plate thickness, is given as 10 mm, and the ultimate tensile strength is given as 150. Factor of safety is given as 3. Okay, so what will be the allowable stress, or I can say maximum stress it can bear, which is nothing but ultimate tensile strength divided by factor of safety. So from here you can easily calculate how much load it can bear, which is nothing but ultimate is given as 150, this is 3, and this is nothing but a megapascal. So 50 megapascal is the allowable stress. So this stress, the allowable stress, is nothing but is equal to load divided by area. What is the area? Area is nothing but, so this is basically a throat thickness, and this is the length of weld, okay, which is basically into the plane of paper. Okay, so this is basically a throat thickness. This is basically a throat thickness. Now, so that means what will be the area? This is the throat thickness T, because this height, which is nothing but H, this is the throat thickness T. This is the throat thickness T. So what will be the area? This throat thickness and the length of this weld. And the length of this weld. This is the area, basically. This is the area. So the throat thickness into the length of the weld, which you have to calculate, and the maximum stress is nothing but 50. So this value is 5000 divided by T into L. So from here you can calculate the length of weld, which is nothing but 100 divided by what is the T. So the throat thickness value you have to calculate. For that, there is a relation. The throat thickness is nothing but equal to the plate thickness divided by root 2. So the throat thickness is equal to, plate thickness is given as 10, and this is root 2. So once you will calculate, this value will be approximately 7.071 millimeter. So you just put this value, then you will get the answer for minimum length of weld, 7.071. So if you solve, then you will get 14.142 mm. Okay. So this is the minimum length of weld is required so that the weld doesn't fail. So the correct answer for this question is 14.12. Sorry, 14.14. Okay, you have to round off till 2 decimal places. So this is the correct answer. So the last question which came from this machine design subject in the GATE. What is the question? The endurance limit of specific grade of steel is same as the yield strength. Okay, that means what is the data given? The yield strength is equal to the endurance limit. Okay, the endurance limit is equal to the yield strength. The ultimate strength of grade of steel is twice of the yield strength. Okay, the ultimate strength is twice of the yield strength. Okay. Now, a component made up of steel is loaded in tension and unloaded in periodically. That means, first of all, you are applying some tensile load, then you are unloading. It is required that the component doesn't fail for at least these number of cycle, which is nothing but 10 to the power of 6. As per the Schoenberg law, consider a factor of safety. That means n value is given 2. The maximum applied tensile principal stress you have to calculate. Okay. So the factor of safety is given as 2. Now, what is the case? Actually, this is basically, let us suppose, a member or component which is subjected to a load. Let us suppose the tensile load is increasing from 0 to sigma. That means you are applying the load value sigma. Okay. Then you are unloading it to 0. That means the maximum value of the stress in this case will be sigma. And what is the minimum value of stress? Which will be 0. So from these two values, can you calculate the mean stress as well as the stress amplitude? Mean stress is maximum plus minimum by 2. And the stress amplitude is maximum minus minimum by 2. So from here, the mean stress as well as the stress amplitude will be equal to sigma by 2. Okay, is equal to sigma by 2. Now, as per the Soderbergh criteria, as per Soderbergh criteria, because it was mentioned that you have to use the Soderbergh law. Okay, as per the Soderbergh criteria, the equation is the stress amplitude divided by the endurance limit plus mean stress divided by the yield tensile strength is equal to 1 by n, where n is the factor of safety. Now, what is the stress amplitude? Sigma by 2, sigma by 2, sigma e, plus mean stress is also sigma by 2. What is the yield tensile strength? This is, which is nothing but yield tensile strength is equal to the endurance limit, which is given in the question. So can I write in place of sigma yt is nothing but sigma e, and the value of n is 2. Now, if I will take sigma by 2 common, then it will become 1 by sigma e plus 1 by sigma e is equal to 1 by 2. Okay. Now, from here, this is nothing but this 2 will cancel out. That means 2 divided by sigma e is equal to 1. So from here, you can easily write the sigma value is nothing but sigma e by 2. Sigma e by 2. That means the stress value, the sigma principal stress value, will be equal to the half of the endurance limit. So you have to identify the maximum applied tensile principal stress. There are the 4 options: 1/4 of the endurance limit, twice the endurance limit, half the endurance limit, and the endurance limit. So the correct answer for this question is option C. So the correct answer for this question is option C. Okay. So I have covered all the questions from the machine design also, which came into the GATE 2025. Thank you so much.